Hello everyone, welcome to our channel, and we'll be discussing today on LeetCode problem number 169, which talks about majority search. When suppose we have uh, an array given, and this array is having n elements. So what we need to do is we have to find out an element which occurs more than n by 2 times. So, to attack this problem, as we already know, like our channel talks about more about our thought process, how to think and how to make a matured idea, how to come up with with a matured idea when we face such kind of problem. So, one simple thing is we have different elements, and we can take these elements as a key, and we can create a map over here. And in the value part, we can take the frequency. For an example, one time one here actually comes 4 times, so one you can keep 4. So this is our key, this is our value. So this key value pair we can take in memory, like a map or something like that, hash table. So with the help of that, you can find out like if this number is greater than in or n by 2, then you got your element. So that is fine, but it takes, what it takes, in worst case scenario, it will take space complexity as on. So to get rid of these things, you can apply, majority search voting algorithm. So this algorithm has two parts. First of all, this algorithm has two parts. The first parts, we are going to predict that whether this element uh, could be a major element or not, right? In the second pass, we will confirm it. We will confirm and verify it that whatever element we have discovered through our process, that element is really occurring more than n by 2 times or not. So it's kind of a validation pass. And you will definitely, I know that you will ask, like, to do that, we probably have to, not probably, we have to, go through the array one more time. Yes, that's true. But the idea is like, we will find in the first phase, we will find out the tentative element which is going to be the major element, and in the second pass, actually, we will confirm it. So let's get into the algorithm first. This is a pseudo code, and in the first section, let's talk about this code a little bit. In the first section, we have actually two variables which plays an important role over here. First one is candidate, and for every element, this definition of candidate might get changed, might not get changed as well, based on the situation and condition. And there is another variable which is going to play an important role, that is count. What is this? Is actually talking about the, or expressing the, or indicating the frequency of or recent time frequency of an element. So if we just see this algorithm, we are actually first of all iterating through a for loop. And initially we are saying like, the first element of this array is going to be our candidate, and his frequency or count is going to be 1. Now every time when we iterate this loop, when we come to the next element, based on conditions, this definition of candidates and counter gets changed. We have so far three conditions. One condition, the first conditions, actually we are comparing with array value with our candidate, existing candidate value, whether it matches or not. If it matches, then we will increment the counter. And if doesn't matches, then we have two more conditions, and these conditions has been named as A condition, B condition, C. In B conditions, that means when there is a no match with our array element, then we can either increment the count based on the count is greater than 0 or not. Sorry, decrement the count based on the count is greater than 0 or not. That means it's a new element and it doesn't have any, a prior weightage towards this, towards to be or to be a major element. So we are decrementing it. If it is a new one, means it is a new one, means it doesn't have any count or it doesn't have any frequency, then we are giving or allowing him frequency with one, and we are actually redefining our candidate uh, candidate variable. So let's go through the example first. I mean, I have chosen these two. I mean, these two arrays are same, but their arrangements are different. Let's talk about this array first. Let's have a dry run on this. So first element is one, and as far as this init stuff, you can say like the candidate is one and the count is one. The second element when appears, that is two, it gets compared with the candidate, existing candidate, and it sees like no, it doesn't match with that. So either it will go to condition B or condition C, but count variable is already one, which is greater than zero, so that needs to be decremented, and that needs to be redefined. So the count variable becomes zero over here, and as condition B has been triggered. Next we are talking about one. This is something which is matching with our existing candidate, so the count gets increment, and from zero it becomes one. Next time again one comes, see, so it got incremented because it has a presence already. So that's why here the frequency becomes two. Now next time when it comes, just like a vote, you can think, next time the element comes like four, it's a new element for him, so it doesn't have it doesn't match with the existing candidate, so B is going to be triggered because the count value is already greater. So we need to reduce that frequency, we need to reduce that weightage, and that's why actually what happened, it becomes deducted, one deducted with an existing frequency. And similar way for the next item also, it becomes zero, but when it becomes again one, you know as it matches with our existing candidate, so it becomes one. So in this way we can find out the tentative stuff, and we can verify it through another iteration, and we can confirm it that what is going to be our tentative major element. Here we can see like the tentative major element is one. In this way, arrangement of array. Now if we talk about AI in this way, the first condition, when it comes like 1 1, because it is kind of init phase. Now in the second condition, when we got an element 2, which is different from the existing element, so the count value will get decremented, so here the count value will be 0, and you can see like the candidate is remaining same, so it will be 1, and here we can say like B condition is happening. Now in case of third element, when candidate and count value has a matching, so in that case candidate will remain same and count get incremented, A condition has been triggered. In the next case, that is 3, when this is actually happening like in a new candidate, so it is going to trigger a B condition B, so you can say like the count value will be decremented into 0. Okay. Now, and the candidate is still 1 because it has not been reset yet. But next time when a new element comes, like 4 comes, so in this case, what happened, the count value is already 0. Here the twist comes, the count value is already 0, so it's a new candidate, as it doesn't match, as it doesn't have any similarity with an existing count, so it becomes the new candidate. So here actually your condition C gets triggered, and you got a new count over here, and that is 1. So in the next case, the it doesn't have any match, because we have already redefined our candidate. So when 1 comes, so A condition doesn't come, so it directly goes into either B or C based on the count value. So count value is greater than 0, that means it is going to be in condition B, and your candidate will still be 1, and your count value will get reduced to 0. See, the transition happening in this phase is very, very important. So here actually you got something like 0, because it doesn't have uh, have any match with our existing candidate. So next time when again 1 comes, in the next iteration, you can see like there is a kind of thing like you have one over here, sorry, yeah, you have candidate, but I am trying to see like when four is one, yeah, in the next time when you comes over here, the candidate still becomes, four, and candidate is doesn't have any match with this one, right? Candidate doesn't have any match with this one, but it got zero, so that means it will go to this else condition and specifically into this block. See here, this is why it becomes very important, because in this block we are redefining our candidate. So from 4 to it will become 1 with a presence of 1, with a frequency of 1. So your answer would be in this area is also 1, in this arrangement is also 1. So actually what we are doing, we are, canceling out these two pairs which have got different values, and the rest of the item we are predicting as the major element, and we are actually giving a new pass to verify that whether this element is a new one or not. Thank you so much. Have a nice time, guys. If you have any comments, please uh, don't hesitate to put comment on this lecture. Thank you.